Alright, so we saw our definition of scientific notation, and like I said, it is a way to rewrite rewrite numbers with lots of digits in a shorthand way. So let's look at some examples. So it says change each number below from scientific notation to decimal notation. So I have a number here in scientific notation. So this would be like the a and then times the 10 to the power of n. Notice how a is between 1 and 10. But I want to turn that into decimal notation. Decimal notation, all that means is just like a regular number, like standard form, the regular way you'd write a number. So what I do first is I look at the power of 10. If it's positive, that means I'm multiplying by a larger number, meaning a number larger than 1, which means my 3.0824 is going to become bigger. Because 10 to the 7th power, remember that's a 1 followed by 7 zeros. That would be 10 million. So I'm taking 3.0824 and multiplying it by 10 million. That's going to get a lot bigger. But instead of writing all that out and doing the longhand multiplication, I just have to move my decimal point. So since it's a positive 7, that means I take my decimal point and move 7 places to the right. So here's my 3.0824. So I'll take my decimal point and I start going 1, 2, 3, 4, 5, 6, 7. And anything that I had to do beyond the numbers that were there, I fill in with zeros. So my final answer is 30,824,000. Alright, now let's look at one with a negative exponent. This would be the same as doing 9.08 times 1 over 10 to the 6th, which would be 1 over 1 million, or 1 millionth, which is a very, 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 very small number. So if I did 9.08 times 1 millionth, I'm going to get a really small answer. So this tells me to take my decimal point and go 6 places to the left. So I'm going to rewrite it, give myself some space. So I'm going to take this and go 1, 2, 3, 4, 5, 6. Let's do that again in case you didn't see it. 1, 2, 3, 4, 5, 6. And again, anything that I did beyond the digits that were there, I fill in those gaps with zeros. So 1, 2, 3, 4, 5, 9, 0, 8, and then you can put a 0 out front. So 0.000000908. Alright, let's go the other way. So here's an example of a number with a lot of digits, 7,420,000,000. So scientific notation is a shorthand way to write it. So the first thing you need to do is find your A value. That's the number between 1 and 10. So you ask yourself, okay, where could I insert a decimal point so that I get a number between 1 and 10? And the answer is right there, between the 7 and the 4, because that gives me 7.42. Now, I just have to figure out what the power is on the 10. So here I was at 7.42. Or here I am at 7.42, but remember the actual number is 7,420,000,000. So I look at my decimal point and I have 3, 6, 9 digits to the right of it. And since it's to the right, this is a positive. So this is 7.42 times 10 to the 9th. Or you can ask yourself, okay, where would I have to move this decimal point so I would be where the original decimal point was? Well, I'd have to go 9 spaces to the right to wind up where it was originally. Look at this next one. This is a really, really, really tiny number. All those zeros to the right of the decimal point tell me this number is very small. So the first thing I'm going to do is figure out where to put my decimal point so I have a number between 1 and 10. That would be between the 6 and the 3, so 6.3. Now I'm going to count from where I put it to where it originally was. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There is 12 decimal places between where I put the new decimal point and where the decimal point originally was. And those 12 decimal places are to the left of where I put it. So this becomes times 10 to the negative 12th power. Or again, I could start where I had the new place and count once, twice, 3 times, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces to the left to get to where the original decimal point was. All right. Okay. And 3 more rules we want to look at. So now we want to see how do we do operations on numbers that are already in scientific notation. So there's the rule for multiplying them, dividing them, and raising them to powers. And you'll notice these rules are very similar to all of those rules we've just been learning about our exponents. So let's do an example with multiplication. Going back up here, this tells us to do the constants. So in this case, 3 times 2 times 10 to the power. In this case, it's going to be 8 plus 2. So 10 to the 8th times 10 squared gives me 10 to the power of 8 plus 2. So 3 times 2 is 6 times 10 to the 10th power. And we're going to leave our answer in scientific notation. So this is 6 times 10 to the power of 10. All right, let's do a division example. According to our rule, I do the quotient of the constants, a over b. So that's going to be 8.4 divided by 4 times 10 to the power of n minus m. So top numerator power minus denominator power. Now be careful here. My numerator is 7, but I'm subtracting negative 4. So I'm minusing a negative 4. So let's do the division here. 8.4 divided by 4, that's 2.1 times, and now 7 minus negative 4 is 11. So 2.1 times 10 to the 11th power. And let's look at the last one here. I'm raising it to a power. So this tells me I raise 4 to the power of 3, and again I'm just following the rule up here. The constant gets the exponent as well as the power of 10. Times, and then this is going to be 10 to the negative 2nd power raised to the 3rd power. So this is 64 times 10 to the negative 6. Now, I want my answer to be in scientific notation. So you need to ask yourself, is this answer in scientific notation? Well, unfortunately it's not, because 64 is not a number between 1 and 10. So what we have to do here is figure out how to change this so this is a number between 1 and 10. Well, I could just put a decimal point there. That makes it 6.4. That was easy. But now I've changed the value of the whole entire thing. Okay? So, I'm just going to cross that out. I want 6.4, but I can't do it so easily. So I'm going to rewrite 64. And I'm going to leave this as it is. 64 is the same as 6.4 times 10 to the 1st. So let's say I just rewrote the number 64 in scientific notation. 6.4 is between 1 and 10. and then I'd have to go one decimal place to the right to get back to the original number, so that's positive 1. Now I have 6.4, and now I'm going to add my powers. This is going to be 1 plus negative 6. So 6.4 times 10 to the negative 5th. And of course you could check it. You can do this on your calculator. Multiply that on your calculator. Multiply that on your calculator. Verify that you get the same answer, and you know that you're good. So there's always ways to check just to make sure that you didn't make a mistake. And that brings us to the end. So we are done with chapter 7. Thank you for being my video audience, and I will see you next week.